electrostatics, there was integration, there was Gauss law, and there you have to integrate the things, and things are little bit complex. Means there you are great use of mathematics, more use of mathematics was there. Okay, but in this chapter, this is comparatively easy. So I have told you about the current electricity in the last class. The current electricity is the study of current. So here, if in the electrostatic we have seen that charge was at rest, and when the charge is at rest, no current is produced. When charge starts moving, motion means motion, then the current is produced. And current, electric current is the flow of charge. Electric current is the rate of flow of charge, and we have calculated the current first. Average current, average current is for a particular period of time, and instantaneous current for an instant of time. Here we have used the differentiation method, and unit of current is ampere. Direction of current is the positive direction of current is the motion of the positive charge. Means direction is same as that of motion of positive charge. If a positive charge is moving in this direction, then direction of current is in this direction. If the negative charge is moving in this direction, then the direction of current will be opposite. And current is again the not the vector, not the scalar. Current is a tensor quantity. And after that, I have told you the differentiation and graph. We have this graph of charge versus time graph. The charge versus time graph is a straight line graph. Like Ohm's law, we have the straight line graph. Resistance is the slope of that. And I have told you when this is one of the most important things. When you will draw the current versus time graph, when you will draw the current versus time graph, please remember this point. When you will draw the current versus time graph, area under this axis, area under time axis, area under time axis will give you the charge, will give you the charge. Like here, I have told you this is the graph, this is the graph, and current here is 5 ampere on the current axis, and the time axis, on the time axis, time is 2, and the graph was the straight line. And the area, we have find the area of this is this triangle. You can say this is the triangle OAB. We have find the area of the triangle, and I have told you the area of this will give you the charge. So what we here we have find the charge. Here we have find the charge. So this is the thing. Okay. Now we have very easy question. Very easy question we have. An electron revolves, an electron revolves around the nucleus electron revolves around the nucleus around the nucleus around the nucleus with frequency with frequency f, with frequency f is here frequency, this is f, small f, and this is the frequency. We have to calculate the current. Calculated the current generated by electron. Calculate the current generated by electron. If you have some idea, then this is if the atom is spherical. If I consider the atom as spherical, means, so in the atom, basically, the center is the nucleus. At center, there is a nucleus, and electrons revolve around this nucleus. Electron revolves around this nucleus. If you have the idea, this electron revolves around this nucleus like this. And electron is a charged particle. Electron is a charged particle, and when a charge is in motion, the current is generated. Here, this electron is in motion around the nucleus. So obviously the current will be generated. That current we have to find. That current we have to find. And before that, I want to tell you the time period. What is the time period? Actually, time period is related with frequency. Time period is, suppose the electron is at A, position A, and this electron started the motion and with some velocity, and after that this electron will be again at point A, and the time taken to complete that one rotation, one revolution or rotation, is the uh, time period of this electron. So time period is this, and time period is given by 1 upon frequency. 1 upon frequency. I am representing time period with this and frequency with f. So I can write from here time period is equal to 1 upon frequency. This is f, and frequency can be written 1 upon time period, no problem. And we know that current is, formula for current is I. Charge flown divided by time. Charge divided by time, in simple words, charge divided by time. And what is the charge on electron? If I am taking here, we know that the charge on electron is 1.67 × 19, but I am taking charge on electron here as -e. Charge on electron. We all know what is the charge on electron, but I am taking here charge on electron is -e. I want to write the charge on electron in terms of this. So charge on electron is -e divided by time taken. And what is 1 upon time is frequency. This is the answer. So current is I is equal to, I is the current, and this is EF. See here, this is the negative sign, and this negative sign shows that the direction of current is in the opposite direction. If the electron motion is in this direction, then the current is in this direction. And I have told you earlier, in the direction of current, I have told you, if the negative charge is moving like in this direction, if the negative charge is moving in this direction, the direction of current will be opposite to the direction of negative charge. Here the electron is moving anti-clockwise. The direction of current is clockwise, means opposite to the motion of electron, because electron is negatively charged. So please note it down. And for nucleus, nucleus is at the center of atom, and electron revolves around the nucleus in the circular orbit. All of you please note down.
Yes, sir. Finish.
Okay. Matthew and Nawal,
Yes,
you
sir.
also please.
Yes, sir.
Okay. And okay. So in this way you can solve. The frequency is given, but you should know what is the time period. Time period is to complete one rotation or revolution. So there is one more question. I is for current and T is for time. And a graph is given like this. Graph is given like this. A graph is given like this, and here the current is 10 ampere at this point. The current is 10 ampere. This is given in question. Here the current is 5 ampere. And this is positive axis, positive axis. Above the origin there is positive current axis, and below the origin there is negative current axis. Here, but time cannot be negative, so I'm just removing this. You have not seen anywhere t is equal to -1 second. Time cannot be negative. Always positive. Moving in forward direction. So question calculate. This question we have to calculate. Number 1. Charge in 10 seconds. Average current in 10 seconds. Average current in 10 seconds, and we have to calculate the charge in 10 seconds. And one thing is also given here. Here at this point the time is 10 seconds. Time is 10 seconds at this point. So first we have to calculate the charge, and I have told you the area under the time axis of current versus time graph gives us the charge. The area under the time axis of current versus time graph gives the charge. So here this area gives you the value of charge, and also this area will gives you the value of charge. This is also under the time axis, and this is one triangle, this is another triangle, and we know the area of triangle half into base into height, half into base into height. I am supposing this O this A, this B, this is C, and this is D. And please remember one thing, charge is a scalar quantity, and we have we have to add the charge. Like if you have 5 coulomb charge and if you have minus 3 coulomb charge, then it will be 2 coulomb. You have to take the charge with sign. So the area above this time axis is positive. This is positive area, and because this is negative, you will take this area with negative sign. Okay. So for the charge in 10 seconds, I am representing it with Q charge, or you can say I am representing it with delta Q also. Charge in 10 seconds means this is the average charge in 10 seconds, means for a period of time they are asking. So charge is equal to area under I versus time graph. So area of this triangle, area of triangle OAB, area of triangle OAB plus area of triangle BCD. This is triangle BCD. And this is, you can write here, this is 10 ampere, and you will take this minus sign because this is below the origin. So this is negative axis. So when you will measure the current on this axis, then you will take it with sign. So area of triangle OAB, half into, what is the base of this triangle? OB. OB is the base, and height is OA. OB into OA. OB into OA. Plus area of triangle BCD, half into base is BC, height is CD. BC into CD. And one information is also given here. This at this point B, the time is 5 seconds. Here the time is 5 seconds at this point B. This is given in the question. So now you can easily find the area. OB is, what is the value of OB? This is OB, this is O, and this is B. This is 0, 5 minus 0. This distance is 5. You will take this 5, and OA is 10. 5 into 10. OA is 10, OB is 5. We'll take 5 into 10 plus half. You will take BC. BC is, this is 5 and this is 10. So you have to subtract these two distance to get BC. 10 minus 5 is 5. Now CD. CD will be, this is CD. So this CD will be equal to this. Actually, this is parallel line. This line is parallel. So CD is minus 5. This distance and this distance is same. This is a rectangle. So CD is minus 5. Minus 5. So please calculate the answer, all of you. The answer will be 12.5 ampere. I have taken this -5 here because distance was in the negative axis. So sorry, yaar, charge is 12.5 coulomb, not ampere. This will be in coulomb. The unit of charge is coulomb. Now we have to find the average current in 10 seconds. Average current in 10 seconds. And average current in, what is the value of average current? Average current is charge flowing I average, I have written delta Q by delta T, and this is the delta Q here. Here, this is the total charge flowing here. So you can take this delta Q if you want. This is delta Q. So the average current is charge delta Q. Charge is 12.5, and we have to find this in 10 seconds. Current in 10 seconds and divided by this. This will become 1.25 ampere. So please note it down.
Sir, can you scroll to the last part of the question of the answer?
Matthew and Nawal, have you completed this?
Yes, sir.
Yes, sir.
So, okay, fine.
Yes, sir, finish.
Now we will study the drift. What is the drift velocity of electron? Drift velocity. In this, we will study how the current is formed in a conductor. Current is generated in a conductor. Drift velocity. And please understand first, and after that you should note it down because this is a little bit conceptual topic. So I want first you to understand. So I am taking a conductor. I am taking a conductor. This is just the explanation. We know conductors have the millions of free electrons. Means you can say conductors have the free electrons. Conductors have the free electrons. Conductors have free electrons. And there are some ions also in the conductor. Means you can say, like if you are taking a copper, you know about the copper positive. Copper positive means this copper has given one electron. This copper has given one electron. In the chemistry, is it right or no? This is like this now. When you heat this copper, and this will give the electron. Okay. So in this way, the conductors have free electrons inside the conductor. So here inside this conductor we have the electrons. We have the electrons inside the conductors. Inside the conductors we have electrons, but these electrons, these free electrons inside the conductor have the velocities in a random direction. Have the velocities in the random direction. Suppose this electron have the velocity in this direction, this electron have the velocity in this direction, this electron have the velocity in this direction, like this. And why it is so? Because now this conductor is an isolated conductor, means this conductor is not connected to any battery, and now there is no electric field applied on this conductor. This is the isolated conductor, and here inside the conductors there are electrons, and these electrons have the velocities in different directions. Because when you take the conductor, and suppose this is the conductor now, and there is a temperature around this. In this room there will be a temperature of, like we can say, a room temperature of 28 degrees centigrade. So due to this temperature, this electron, these electrons gets the energy due to the temperature, heat energy. Heat energy is transferred to the electron due to the temperature of room, and due to this heat energy these electrons perform the random motion, means the velocity of these electrons is in the random directions, Okay. Got my point?
Yes.
Yes, sir.
This is all inside the conductor. We cannot see this. We cannot see this. We can just analyze this. I am not sure that this electron is moving in exactly in this direction, but I am having an idea that this electron have the random velocity because of thermal, or temperature. Okay. So now what I am doing, I am just applying the electric field. And we know that this is the electric field, and when a charged particle is placed in the electric field, this charged particle will experiences a force, and this force is equal to F is equal to QE. If a charged particle is negative, then this will experience the force in the opposite direction of electric field, and the magnitude of this force is again QE. So when you apply the electric field, suppose the electric field is in this direction, and due to this electric field, these electrons will experience the force in the opposite direction of electric field, and they will move like this. The electron will move like this. And these electrons now, after applying the electric field, moves like this because of this force, because now there is an external force on these electrons. Okay. And due to this, the current is generated in the conductor. Now there is a proper motion of electron. This is just the basic idea, and now we will discuss this in detail. So drift velocity is the average velocity with which electrons moves towards the positive end of conductor under the action of, or you can say when you apply the electric field, under the action of electric field. So initially this is the conductor, this conductor have electrons as well as ions. This conductor have electron and positively charged ions. I am representing ions with positive charge like this, electron and positive charge ion, then electron, then positive charge ion, electron, like this. This is electron, free electron you can say. And this is ion, and this ion is not free. Means this ion will not move. Only the electron will perform the motion. So initially, these electrons have velocities in random direction, like this is u1 in this direction, this is u2 in this direction, this is u3 in this direction, and accordingly there are many electrons inside the conductor. So they have velocities in a random direction, like the gas molecule. Gas molecules have also the velocities in different directions. So here you can say u1, u2, u3, and if there are n number of electrons in the conductor, so you can say un. These are the thermal velocities of electron. Thermal velocities of electron. Thermal velocities of electron. These velocities are due to the temperature only. Due to the temperature only. And if I want to find the average thermal velocity of all these electrons, if I want to find the average thermal velocities, so it is found that when we find the average thermal velocity, it is found that average thermal velocity of, if there are velocities in this direction, in this, in all the directions, in the random direction, and when you will take the average of velocities, all the velocities, you will get 0. Means u1 plus u2. I'm just coming. Okay. So when you will take the average of this, I am supposing there are n number of electrons here in the conductor. Un is the velocity of nth electron, and when you will take the average, this is n. Average is taken as, what is the average? Is the sum of velocities divided by the number of velocities. Here the number of velocities means number of electron, that is n, and this is come out to be 0. This is come out to be 0. This is the case when you have not applied any electric field. Now finally you have applied a electric field across the ends of conductor. Finally, this is the same conductor. This is the same conductor, and you have connected this conductor with some battery, with some battery. This is the EMF of battery. And now the electric field will be produced. Now the electric field will be produced due to this battery in this direction. The direction of electric field is from positive to negative direction of electric field. And we have electrons inside the conductor, and these electrons will experience a force in the opposite direction of electric field. Force in this direction of electric field. So you can say, on applying battery, on connecting conductor with battery, electric field is generated inside the conductor due to this battery. The electric field will be generated from positive to negative terminal. Electric field is generated inside the conductor, and an electric force will be experienced by the electrons. By the electrons. By the electrons. So the electric field is generated inside the conductor in this direction. Like this, the electric field is generated. And we know that whenever a charge is placed in an electric field, due to this electric field, there is a force on this charge, and this force have the value charge into Q, charge Q into E. If a negative charge is placed, then the direction of force is opposite to the direction of electric field. So I can write this as minus QE if I want to write in the vector form. This is F1, suppose this is F2. This is F1, this is F2. So now see here, here is the electron in this electric field. Here is some electric field, and here is the electron. So the force on electron in the vector form, force on electron because electron is negatively charged. So F is the force on electron. Right here, force on each electron, because each electron will experience a force. Is equal to charge on electron minus E is the charge on electron, and E. This is the force on electron. Force on each electron. Guys, have you understood till here?
Yes, sir.
Yes, sir. Yes, sir.
You should only know, or you should only know some basic things. Whenever a charge, whenever a charge is placed in an electric field, it will experience a force, and that force is given by the formula F is equal to QE. And I have just write that force in the vector form. Force is a vector, electric field is a vector. I have written this force in the vector form. Here is this electron, and the electric field is in this direction inside the conductor. So this electron will experience a force in opposite direction of the electric field, and this is F. F is the force on each electron, and I have written this force F in the vector form. Okay, please note it down till here, and after that we will move forward.
Yes, sir. Finish.
Yes,
All
sir.
of you,
Yes, sir. Yes, sir.
this one also,
Yes, sir.
Nawal and Matthew.
Yes, sir.
It means completed all. Okay.
No, sir.
Yes.
Can you show that paragraph?
Okay, fine. This is the electron, and there will the ions will also there here. Okay, inside the current, inside the conductor, ions will also be there, but I have not drawn the ions.
Don't, sir.
This is very important thing. This, when you place a charge in an electric field, the charge will experiences a force, and the direction will depend on the magnitude of charge. Means whether the charge is positive or negative. So I am taking Me as an electron have the charge, and electron have the mass also. If Me is the mass of electron, and do you know force is equal to mass into acceleration? Mass into acceleration. This is the formula given by Newton's second law. This is the formula we have from the Newton's second law. And A here is acceleration. I can write acceleration is equal to force divided by mass. If I want to find the acceleration of electron, if I want to find the acceleration of electron, then I can write acceleration is equal to force on electron divided by mass of electron. And if I want to write this in vector form, then acceleration is vector and force is vector. So acceleration on electron, acceleration of electron is equal to force on electron divided by mass of electron. So acceleration of electron is equal to, I am just representing acceleration with A only and force with F only. And force is this minus divided by mass of electron. This is the equation 1. What we have done initially, we have no electric field, and we have no electric field means there is no force on the electron. and when we applied the electric field, there is a force on the electron, and due to that force, the acceleration is produced, and we have calculated that acceleration here. But here, what happens? What happens in this case here? This electron will experiencing a force in this direction, in the opposite direction of electric field, but there will be ions also in the direction of electron. When the electron will move, there will be, suppose this is the ion and this is the electron, like this. So there will be ions also, and these electrons will definitely collide with the ions. When electron will move from negative to positive terminal, then the electron will collide with the ions, because there are ions also. So here we can write electron will collide with ions this is a positively charged ion. Suppose the electron is here initially, and this electron is moving in this direction. This is collided with this ion, and after the collision with this ion, there will be another ion, and after the collision of this, the electron will collide with another ion. Electron will collide with ions. After one collision, you can write after one it moves, and after another collision it will move. Means you can say, suppose you are here and you are running in this direction, and you are running in this direction, and there are some uh, persons here, and you are running very fastly, very fast. So when you will move, uh, when you will run, you will collide, and there are number of peoples. There is in a less space. There are more number of people, and when you are running, then you will collide with the people, and when you will collide with this, maybe you will go with, maybe you will move little bit this side, okay, and after that, what you will do, you want to go in this direction, you want to go in this direction, but you have collided with this person, and you have now your direction is changed little bit, means now your direction is somewhat this, and after that you have uh, after that again you are running, and you are moving in this direction. Now you have collided with this person, after that also your direction will change. So same is the case with electron. This is the, you are the electron, suppose you are the electron and you are moving. Okay. So electron will collide with the ion, and after one collision it will again try to move in this direction, but after this collision, the direction of motion of electron will change. And there is a relaxation time. There is a time here will be a relaxation time. Relaxation time means relax of electron, simply. So so relaxation time is this. This is the relaxation time. Suppose this is electron, 1 electron. This is tau 1. For the relaxation time is time interval between two successive collision of electrons with ions. So this is the electron, and this electron will collide with this ion. After that, this electron will collide with this ion. So in between the collision, there will be some relaxing time, means the time for which, suppose this is the ion, and this is the electron, and this electron is colliding with this ion. So when the electron is at this position, and when the electron finally was is at this position, so the time in between is the relaxation time. But for the two collision, means electron is moving from here to here, one collision, from here to here, one collision, the time taken is known as relaxation time. Suppose tau 1 is the relaxation time for electron 1, tau 1, tau 2, tau 3, and there are n number of electrons, so I will say are the relaxation time. See the word relaxation time for the electrons. For the electron, and after the collision with this, first the electron will collide with this. After this collision, the electron will collide with this, and after this, the electron will try to move in this direction with some velocity v1, because the force is trying to pull the electron in this direction. Now initially the electron has some velocity, like you can say initially the electron have some u1 velocity, and finally the electron have this velocity. Finally the electron have this velocity, final velocity, and we want to find the relation in between the initial and final velocity, and we have the formula v is equal to u plus at. Do you know this formula, Matthew, Nafisa and Nawal? V is equal to
Yes,
u
sir.
plus at. Matthew, do you know this
Yes,
formula?
yeah.
Okay. V is the final velocity, u is the initial velocity. This is final, this is initial, and a is acceleration, t is time. So if we want to find the final velocity of electron after the collisions, final velocity of electrons. So for first electron, this is the first electron we have. I am supposing this as first electron. There are n number of electrons, first electron, and we will write the expression first for the first electron, and accordingly we will write the expression for n number of electrons. So final velocity of electron v1 is the final velocity. This v1 is the final velocity here. And u1 is the initial velocity of initial velocity. For the first electron, the final velocity can be find out with the help of this formula. Final velocity is equal to initial velocity plus acceleration into time. I am writing this in the vector form. Velocity is vector, this is again velocity, this is vector, acceleration is vector. For the first electron, this is the expression. So v1 is equal to u1 plus, and please remember one point, the acceleration here is same for all the electrons. Acceleration is same for all the electrons. So what is the value of acceleration? E by me. E by me, put the value of acceleration here, minus E, capital E, into divided by mass of electron. And what is the time for the first electron? Tau1 is the time. This is the time. Tau1 is the time. So this is the expression for the first electron. So for the second electron, you can write similarly. Acceleration is same. And for the second electron, instead of tau1, you will write tau2. Accordingly, you can write for nth electron. You can write for nth electron. As I have supposed there are n number of electrons. So un plus acceleration is same for all the electrons. Mass of electron into tau n. Now, if I want to find the average, this is the final velocity. This is the final velocity of electron. Now, I am taking the average of final velocity. Finally, what will happen? The electron will move in this direction. Finally, the electron will try to move in the direction opposite to that of electric field. And if I want to find the average, final average velocity, this will become v1 plus v2 plus v3 plus, and so on. There are n number of electrons, and divided by n. Average is sum of the velocities divided by the number of velocities, means number of electrons. V average is equal to, put the value of v1 here, v1 is equal to u1 plus this and this. u1 plus minus e vector, this is vector, mass of electron into tau1, and for v2 write u2 and plus, this will minus divided by me. and this is tau 2, and accordingly you can write for nth electron un plus minus e minus e and capital E vector divided by mass of electron into tau n. This is tau n, and this is divided by n. This whole is divided by n. So from here, this u1, this u2, u3, un, can I write like this? U1, this is u1, and from here this is u2. I can write this like u2 plus u3 plus un divided by n. I can write like this. Pause. And here I can write. Here I can write this. See here, we have this E by ME. E by ME is common from everywhere. From here, E by ME is common. From here, E by ME is common. So I can write plus common of minus E by ME. And now we have tau 1 plus tau 2 plus tau 3 plus tau 4, tau 1 plus tau 2 plus tau 3 plus, and so on. This will become plus tau n. And this is divided by n. Getting or not, guys? Getting or not?
Yes, sir.
Getting, sir.
I have just done the addition. I have taken the u like this, and this is common from this all this term, from this term, from this term. This is common, and this here. And we know that this thing is 0. This thing is 0. This is u average, and u average was 0. This is, you can write like this. This was the u average. So plus minus E by mass of electron, and this is known as the average relaxation time. Tau 1 is, what is tau 1? Tau 1 is the relaxation time. Tau 1 is the relaxation time for electron 1. Tau 2 is the relaxation time for electron 2. So this whole term is the average relaxation time. This is represented by tau. Tau is average relaxation time. The average of relaxation time. Average relaxation time, and this term is 0, we know. So the average velocity of electron is equal to minus, and here is a vector. Here E by mass of electron into tau. This average velocity of electron with which the electron moves from the negative terminal to the positive is known as the drift velocity. Expression for drift velocity. This is the expression for drift velocity, final expression. And if I want to write this, the magnitude, and I will represent this V average with V suffix D. Drift velocity, I am just writing the magnitude. I am just writing the magnitude. This will be E divided by E tau divided by M, mass of electron. So you can remember this for solving the questions, this formula. Vd is the drift velocity. So I have written earlier, drift velocity was the average velocity with which the electrons moves towards the positive end of the conductor under the action of electric field. See here, this is the average velocity. We have just calculated the average velocity, and this average velocity is the drift velocity. So this is the derivation for the drift velocity. First we have calculated the force, after that we have calculated the acceleration. From that acceleration we have defined a relation between the initial and the final velocity, and after that we have calculated the average final velocity, and that final velocity is known as the drift velocity. Please note it down. And if you have any doubt, please ask me, Matthew, Nawal, and Nafisa. If you have any doubt, please
Yes,
ask me.
sir. Understanding.
And please note it down. I am just coming in 1 minute. Completed this?
Yeah, we complete this relaxation time. Okay.
I'm sorry. Okay, from here now. This
Yes.
please note down. Relaxation time is just the time of relax for the electron. When the electron is not colliding, means when the electron is just about to collide with ions, that time is the relaxation time between the two successive collision of electron with ions. And please ask me to scroll down when completed.
So can you scroll down?
So first there is no electric field, means electrons is moving like this, like in the random direction.
So can you
And
scroll down?
yeah, when the electric field is applied, then there is a proper velocity, means proper direction of motion of electron due to the electric force, as you have applied the electric field and the electron is a charged particle. So due to that electric force, the electron tries to move in the opposite direction of electric field, but unfortunately there are ions in the conductor, and electron collides with these ions. Okay. And from the second equation of motion, that is v is equal to u plus at, we have calculated the final velocity of electron after collision, after two successive collision with ion. And after that, we have taken the average of final velocities. And that average of final velocities is the drift velocity. So you can say the electron will move in the opposite direction of electric field, because electron is a negatively charged particle. Or you can say the direction of drift velocity is opposite to the electric field. From the sign you can also understand, and from the, as you know that the electron is a negative charge, so it will move opposite to the electric field. And here is a vector. This is a vector. U represents the initial velocity of electron before the before applying the electric field, and V represents the final velocity of electron after applying the electric field when the electron is in motion. E is the charge on electron, minus E is the charge on electron. A represents the acceleration, tau represents the relaxation time. So tau represents the average relaxation time. Nawal, have you completed?
Yes, sir.
Nafisa, have you completed?
Yes, sir.
Okay, good. Have you understood? You have to practice this 2 or 3 times. This derivation. Matthew completed?
Yes.
Okay. So see here, we have drift velocity. So write one note. Write like this. Direction of drift velocity is opposite to the electric field. See here, this electron will move in this direction with drift velocity, and direction of drift velocity is this, and direction of electric field is this. Write one more point on if what happens when we increase the temperature. On increasing the temperature, here now you have increased the temperature here. So due to the temperature, the collision of electron will become fast. The collision of electrons will become fast, and the relaxation time will decrease. On increasing the temperature, the electron collide fastly with ions and see here, when the temperature will be increased of the conductor, then inside the conductor, due to that temperature, the motion of electron, means you can say the collision of electron with the ions will become fast, very fast. Okay, the collision will become fast, and when the collision will become fast, means the time of relaxation of electron will decrease. So you can say and relaxation average relaxation time decreases, tau decreases. And what happened when tau decreases, drift velocity will also decreases. From here, when tau will decrease, drift velocity will also decrease. So you can say Vd will also decrease on increasing the temperature. So do you have any doubt, anyone? Matthew, Nafisa, and Nawal, please, you can ask me,
No doubt, sir.
because there are a number of things in this derivation. Number of things. If you have any doubt, then You can ask me, otherwise no problem. So have you completed this
Yes, sir.
all? Okay, fine. So that's all for today. And please revise your notes and try to practice this at least for 2 times or 1 time. Okay.
Yes, sir.
Nawal and Matthew, you can leave the meeting. Nafisa, please you stay here, and Nawal and
Thank
Matthew,
you,
you
sir.
can leave the meeting.
Okay, sir. Thank you, sir. Have a nice day.
Hello, Nafisa. So
Yes, sir.
earlier I have discussed. I'm just giving the idea what I have discussed. Okay.
Mhm. Yes, sir.
Yeah. So this chapter is the current electricity. This chapter is the current electricity, and in this chapter, current electricity is the second unit. In the first unit, you have you have study about the name of the first unit was electrostatics. Electrostatics. There, statics means uh, no motion, means at a state of rest. In the electrostatics, we have studied the charges at rest. Now, in the chapter current electricity, we will study the charges in motion. See here, when the charge was at rest, when the charge was at rest, we have studied that is electrostatics, and when the charge is at rest, then no current is generated. Current is only generated when charge is in motion. So now the charge is in motion. Now the charge is in motion, and motion can be accelerated motion, and motion can be uniform motion. Suppose that the charge is moving with a constant velocity. The charge is moving with constant velocity. In this case, you can say if the velocity is constant, then you can say the acceleration is zero. Acceleration is zero means uniform motion. So in this chapter current electricity, we will only study the uniform motion, means we will consider acceleration equal to zero, or you can say not acceleration equal to zero. You can also say that we will study here the charge motion of the charge with constant velocity, with constant velocity. And after that we have the unit electromagnetism. We will discuss that when we will start. And the first term is the electric current. Electric current is the rate of flow of charge. Suppose this is a conductor. Suppose this is a conductor. A delta Q amount of charge is flowing through the through this cross section of the conductor. Okay. And so if you want to find the current, then current is charge flown divided by the time interval. So I have calculated here the average current. Average current is delta Q divided by delta T. Delta Q is the amount of charge flowing in delta T time. In delta T time. I'm just taking your 5 minutes. Delta T time. So average current is delta Q by delta T, and instantaneous current is dQ by dt, like the instantaneous velocity. Where when you calculate the current for very small amount of time, when time is approaches to zero, then that current is known as instantaneous current, and after that unit of current is calculated from here. The unit of charge is coulomb, unit of time is second, SI unit, and charge per coulomb is ampere. Direction of current is when a positive charge moves in this direction, the direction of current is same. Means direction of current is the direction of motion of positive charge.
Yes,
And
sir.
current have what?
No, I just said yes.
Okay. Current current is the current have the magnitude also. Like you can say 2 ampere current, 3 ampere current, and current have direction also. Means current is flowing in this direction, current is flowing in this direction. Like here the current can flow in this direction, and in this direction also the current can flow. So current is the direction of current. Oh, sorry, current have magnitude and direction, but current is not the vector quantity. Current is not the vector quantity because current does not follow the laws of vector addition. See here are two currents at 60 degree. At 60 degree, there are two current. Direction of current is this, and another direction of current is this. This is 2 ampere current. This is 3 ampere current, and the resultant of this, when you will add this, we can add the current directly. 2 ampere plus 3 ampere equal to 5 ampere. Now I have changed the angle to 90 degree, and again we get the 5 ampere current. Means this current is not following the vector laws. And I have told you in the vector, when you change the angle between two vectors, the resultant will change, but here the resultant is same. So current is not a vector quantity, not a scalar quantity. Current is a tensor quantity, and this tensor quantity is not is a part of your syllabus, so you can consider current as a scalar quantity. And after that, I have told the differentiation to. Do you have idea about the differentiation?
No, sir.
Okay. So I am just leaving the differentiation part for now, and we will discuss this. So after that, I have told them how to draw a graph. How to draw a graph, and when you y is equal to mx is the equation of a straight line graph passing from the origin, and there is a slope tan theta, and when you will draw the charge versus time graph, this will be a straight line. This will be a straight line, and after that, uh, graph between current and time, and area of this graph is the charge. We have done the question here. This question also, and this question. Today I have started from here now.
Yes, sir.
So is it all right from here now?
Yes, sir. Yes, sir.
Charge is equal, current is equal to charge divided by time, and after that we have this question. So we have just calculated the area for finding the charge. I have told you the area of graph under time axis of current versus time graph is the charge. So here we have calculated this. Now we have the drift velocity. Um, uh, do you have class tomorrow?
Yes, sir. Chemistry.
No, with me. I am just asking. Just asking with me. You have class?
I'm not like informed in advance. Like I would always be informed like on the day I have classes with you. So yeah.
Okay. So we will discuss the differentiation in the next class. Okay.
Yes, sir. Okay.
Okay. So from here, if you have any problem, from here to here, if you have any problem, you can ask me. Okay.
Yes, sir.
If you have any problem, then you can ask me. Otherwise, and
No,
please,
sir.
please. Okay, fine. That's good. And please try to revise your notes. And you have not completed this lecture. First lecture you have not
Yes.
completed, no?
Yes, sir.
Okay, I will try to give you the notes. Okay.
Do I have to learn both, like the first chapter and this chapter?
What?
Should I like learn both chapters, like the one before and this one? Which one should I focus on more? I'm confused.
Actually, this time I will say now you are studying this chapter. So now
Okay.
more focus on this chapter and less focus on the previous chapter. But you have to complete that also.
Oh, right.
Okay,
Okay.
because both are coming in the examination. So I will say that first focus on this chapter, and after that you have the